Now this is the one of the most important question which is come in NET exam every year, almost every year. It is also come in GATE exam also. So this is a cardinality. Okay, cardinality number question. Almost every year this type of question has come. So before starting this question, I have to give an example. So my question is, how many functions are there from set of natural number to 0, 1? Okay. How many number of functions there from set of natural number to 0, 1? If we construct, say f is a function like this, the values like this: 1 0 0 0 1 0 0 0 0 0 and so on. That's mean this a function arise. That's mean f1 is equals to 1, f2 0, f3 0, f4 0, and f5 1, and f6 f6 0, f7 0, f8 0, and so on 0. Similarly, you can say that 0 0 0 0 1 0 0 0. This all parts are 0. Just f5 is equals to 1. Similarly, you can say that f1 1 1 1 1 1 1 1. That means 1. That means at every natural number it occurs 1. Similarly, you can say that 0 0 0 0 0. That means at every natural number it occurs 0. So if you know the binomial representation, easily you can say that this is an example of a binomial representation of a real number. Okay, that's mean every binomial, take any binomial representation. Suppose 1 0 1 0 1 0 1 0. Okay, you can get also this type of function where f1 is equals to 0, f1 is equals to 1, f2 0, f3 1, f4 0. So basically you can say that, say every function basically represent a binomial representation of a real number. You can say that every function from n to 0 1 is basically a binomial representation of a real number. That's when you can say that by all function you can overlap the real line, because we know every real number can be every real number has a binomial representation. Okay, and every binomial representation is basically is a function. That's when all function is overlap, that's only fill the real line. Okay, how many real numbers are there? Uncountable. That's mean how many binomial representation there is uncountable. And every binomial representation is basically is a function. That's mean how many functions are there? Uncountable. So therefore, you can say that the number of function from n to 0 1 is a uncountable. Basically, we can show by using a formula. There are so many person just say that the number of function from n to 0 is just you have to use the formula 2 to the power n0. Okay, because this number is a number of elements 2, so their number of function from n to 0 is 2 to the power n0, as the cardinality of n is n0. As n0 is infinite, this is always uncountable. You can search it here. You can see this theorem is everywhere. Any textbook you can see this number is uncountable. So therefore, okay, but just I want to give an example for better understand. Okay, I think you understand this type of function is the number of function from n to 0 1 is uncountable. So if n to 0 1 is uncountable, so obviously if you take q to q is a parent set of n. If number of function from n to 0 1 is uncountable, so obviously you can say that the number of function from q to 0 1 is also uncountable. So therefore this is uncountable. Now if you go from q to 0 1, okay, this is uncountable. And if, instead of this, if you go 0 1, instead of 0 1, if you go q, that's the number of function from q to q. If q to 0 1 is uncountable, obviously you can say that the number of function for q to q is also uncountable. So this is uncountable. Now the next is the set of all subset of n. Easily you can say that nPn, this formula is the power set formula is to the power n0, as the cardinality of n is n0. As n0 is infinite, this is uncountable. So therefore all of 3 are uncountable. So obviously answer is this. That means this is countable, but I will prove that this function is okay, this function is countable. How? So before this I want to define a number n1. N1 be all of the function which uh, non-zero only 1 point, non-zero only 1 point. That's mean if one, suppose just give an example, if r is equals to 0, r not equals to 1, sorry, r not equals to 1, and if 1 not equals to 0. So this type of function. That means there is another function if 2 not equals to 0, and the remain all parts if r is equals to 0. So n1 be the set the number of all functions which is not 0 only 1 point, and which is 0 the remain points. So as r is rational number, then easily you can say that this type of function is countable. Okay. Now, if you take n2, n2 is the set of all function which vanish only, which does not vanish only 2 point. Okay, that's been take a function f1, if r is equals to 0, where r not equals to 1 and r not equals to 2, and f1 not equals to 0, f not equals to 0, f2 not equals to 0, this type of function. Again, r is, since this is a real rational number, easily we can say that this is also countable. Okay, so that's been nk is the number of all number, the set of all function which vanish, which does not vanish at k point. Okay, okay, that means each is countable, and this is also countable. So easily you can say that the set of all function from q to 0 1 which vanish outside a finite set is obviously less than, it's obviously less than n1 union n2 union n3 union dot 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 nk and so on. Basically this is a countable union of countable sets of, okay, countable sets, countable collection of countable sets, n1 n2 n3 n4 nk and so on. That means this is a countable collection of countable set, and we know that countable collection of countable set is countable, and this cardinality of this set is less than this, then obviously this set is countable. Clear? Wow, very good. So I think you understand. If you have any problem, any query, you can ask me. You ask, I solve. Okay, thank you.